metric system. I know we started this yesterday, but I want to go back and hit the high points to make sure we are all on the same page and all that good stuff. So, what is the metric system? I know I asked you this. So, would you be breaking the speed limit in a 40 mile per hour zone if you are traveling at 60 kilometers per hour? No, you would not be. Now, if you solely look based on the numerical values alone, are you speeding? Yes, but what added to it to change that? The units. So, as far as we know, as far as we understand, the units are going to be the most important attribute to any measurement that we give. Okay? And we talked about that. So measurements represent quantities. And what are quantities? Quantities are numbers. So if you did not write this yesterday, make sure you write this. Quantities are numbers. So if I ask you to start cooking me something, or if I ask you to go buy me something, do I have to tell you an amount for you to be able to do that stuff? Sure, absolutely. But is it also important that I tell you a unit on that amount? Because if I said go buy some Coke, how much? What if I said go get me 3 of them? 3 what? 3 cans, 3 bottles, 3 cases, 3 what? Okay, you have to give me a unit on the end of that to make it make sense. Now, I don't know if you guys wrote this, but if you did not, please write this for me. Okay, measurements are not units, but do they go together? Yes, you cannot have one without the other. Okay, you cannot have one without the other. We talked about how teaspoons and tablespoons are units of measurements, and we talked about how volume is what they're measuring. Okay, so what if we talked about a centigram? Okay, a centigram, is that a measurement or a unit? A unit. And what are you measuring with a centigram? Not weight. Mass. There is a difference, and we'll talk about that here in a little while. Okay? The choice of unit depends upon the quantity being measured. So this is where I actually want to stop today and kind of do a small little demo. All right, so here's my question again. Is this table a certain size? Do our measurements yield the same amount? No. Why not? Did we use different tools of measurements to determine the size of this thing? Yes, okay, we did. Now, what we actually measured earlier is we measured this. Oh, I'm getting ahead of myself. The problem with this is history. Long, long, long time ago, when people started traveling the world, they started trading in grains, trading in fabrics, trading in hand goods, and in currency. What they realized is their system of measurements were totally different. Now, in the video we watched yesterday, I don't know if you caught it or not, but did you see it was like a king standing up on a podium and they had a scale or a balance and they had to put stuff up on it to measure their weights? So what they were realizing is the kings were changing their masses without actually telling them they were changing it. And so finally they said, if we standardize everything, we can make sure all of our measurements match up. So if we were going around the world and we were trying to determine a certain distance, okay? So, if we used, and again, this is being funny, not politically incorrect. So, James, let's say, or Brad, let's say we went to England for you, and we said we want to measure distance, and we use your foot. Okay? Doran, we went to Africa, and we measured your distance in foot. Would we yield the same distances using different feet? Would we? No, we wouldn't. Well, what if we come to the United States and then wanted to measure distance in my feet? That's not going to give us accurate measurements. So what did they invent around the world to help standardize length measurements? The meter stick. Okay. So does anyone remember exactly how long a meter is by definition? Remember, we have the Earth. Okay, and what's the thing that goes around the Earth? The equator. And what's this thing way up here? Okay. So a meter is 1/1,000,000th. Or was it 100,000? It may be 10. I don't remember exactly the value, but I feel dumb now. But it's 1/10,000,000th of the distance between the equator and the North Pole. Okay, so that's where they came up with a meter from. And so we standardized it. And what we actually figured out is we actually measured this thing earlier, and it was 9.74 feet. Okay, so that table, according to that meter stick, is 9.74 feet. So whose foot was the closest? Brad. So Brad's foot is almost a foot. Okay, does that that make sense? Almost. So this is how we can standardize our measurements. So instead of using different tools to measure the same thing, we now have them standardized. So that's what the metric system is for, and that's why it's important. Now, this is, did y'all get this? Okay, fantastic. All right, so this is where we want to start then. So again, we already know it was developed by the French after the French Revolution to go around the world to say we want to make sure that what we're measuring is standard across the board. We're not using different people's feet anymore. We're not using different people's hands anymore. We're not using different grains. Okay? What do you think the biggest fight was over? In different measurement stuff. Money. Money is the root of all evil, right? Everything always comes down to the powerful money. And so what they realized is their money values were totally different. And so some people thought their money was worth more than other currencies, and how you kind of standardize that issue. Now, do we have the same currency worldwide? No, we sure don't, and we never will, okay? There's theories about what happens if we ever go to a worldwide currency, but I'm not going to get into that. Oh. Have you ever heard of the Illuminati? Do your own research, okay? So the big deal with the metric system is that it's based on the powers of 10. So what this means is all you have to do is move a decimal. Okay? And I've asked this several times, but I'm going to ask it again just to make an emphatic point. How many inches are in a foot? 12. How many feet are in a yard? 3. How many feet are in a mile? 5,280. So the problem is that those numbers have to be memorized and they have to be applied. Well, you can do all that memorization and all those calculations, but the metric system, all you have to do is move a decimal. How many of you would rather just move it 4 or 5 places left and right? It's a lot easier, right? You don't have to pay attention to anything. You don't have to do any calculations. You can, but it's just as easy just to move the decimal left and right. So that's why the metric system makes it simpler for everyone to comprehend and understand. Now, it's used by everybody except how many countries, including us? 3. We're one of the 3. Scientists, abbreviation for System International, and there are 7 base units. So we're going to talk about those 7 base units in just a second. As a matter of fact, there is some room. Hold on, we're going to get to that. Hold that thought. That's right, there are some weird strings blanks. Yes, with notable exception of the U.S. It's right there. No, it was Liberia and Burma. Okay. Burma is around Mongolia, though. Now, here's the deal. So these are the 4 basic ones. We do distance quite often, right? We do volume quite often, we do mass quite often, and we do temperature quite often. And these are some of the basics. I think we've talked about this. We know the basic unit is going to be a meter. Volume, this is kind of weird. We'll talk about volume later. Now, the problem with the mass is it has the kilogram as the base unit. Have we talked about this? What is about 1 gram? A paperclip. So we have talked about it, right? Are you at least 1,000 paperclips? Yeah, so since you're about 1,000, more than 1,000 paperclips, we use the kilogram as the base unit because it would be way too many numbers to give it a gram value. And then temperature, we can do Kelvin or Celsius. These are the main 7. These are the basic 7s. Okay. Now, up there where there are 7 base units. Here's what I need you guys to write. This right here. Actually, I'm going to change this. Okay, so an amount of substance, that's what we're measuring. The amount of substance, just like a mass, just like a temperature, just like a time, just like a volume. An amount of substance is something that you can measure. Okay? An amount of substance is something that you can measure. Now, you don't have to write this down. I'm just going to go ahead and show you what I'm kind of give you an easy reference point. I promise I'll move. always misspell Celsius. I don't know if that's right. I think that's wrong. I don't know what it is, but it's fine. It'll work. So basically, what I'm just trying to give you is a reference point of what it's actually kind of like. So, view green amount of substance is a measurement just like temperature is a measurement. Okay? The abbreviation, instead of writing the word temperature, which I've already abbreviated because I'm too lazy to write the word temperature, what letter can you write? For temperature, you can write T. Now, what unit do we have for temperature? Celsius. And instead of writing Celsius or even Fahrenheit, do we have an abbreviation for that word? Yes. Same exact concept, but we're talking about a different form of what we're measuring. What we're trying to measure is an amount of substance. So let me ask you a question. What is everything in this universe made up of? Matter. And what is matter made up of? These things, right? Elements, atoms. Okay? So, if I handed you a paperclip, would you agree that this thing is made up of a bunch of those things? Yes. What if I asked you to count the number of atoms in this thing? Could you do it? Now, it's physically impossible because you can't see them. However, through years and years of study and research and experimentation, we could actually determine the number of atoms in this thing through some basic calculations. It's not going to get you in a run. And it's all dependent upon how much this thing weighs and the type of elements that are present. So let me ask you something. If we, as students and teachers, represented different elements, do all of us weigh the same? No, we don't all weigh the same. So just like elements, they all have different masses. So if I take this man and fill it up with a bunch of me, would it weigh completely different if I take this man and fill it up with a bunch of you? Yes. So the masses are going to be completely different. So depending upon what this thing is made out of determines how many atoms make it up based on its mass. And we're going to talk about that a little bit later on. So here's the deal. The way we determine how much stuff, the amount of substance or stuff in this thing, is based on the mole. Now, I know what you're thinking. We get where T came from in temperature, right? Where in the world did M come from? I don't know. I don't know Peru. Okay? Just like Celsius. That's kind of a strange word, right? Well, the problem with you guys, real quick, really, when you see the word mole, you think of Rufus from Kim Possible, don't you? Okay? No, we're not talking about Rufus, all right? We'll pick up tomorrow.